It's midnight, almost 1:15 a.m., and I'm recording this video. So yeah, this time I'm back with a new project which is called Text-to-SQL. In this project, I have used Node.js, LangChain, and LangGraph in order to build this complete orchestrator. So let me just explain you first this diagram so that it becomes easier for you. So in our main diagram, the important person is the user. So the user will ask a question and it will be passed on to the intent classifier. So the role of the intent classifier is to identify the intent, whether the user's question is related to our business or not. So for that, you can use some system prompt and try to identify it and give it a structure and uh, take the output as a structured output. So in which I have used a attribute called confidence level. So between 0 to 1. So if it's near to 1 means the intent is close to our business. If it's near to 0, then you can directly give a natural response that it's not related to our business and exit the complete graph. Then if it's related to our if the intent is related to our business, pass it on to the query planner. So the role of the query planner is to identify which all tables will be required. Is there any join operation required in order to resolve the user's query? So it will just give us some metadata information. So based on that metadata information, we will pass that to the table retriever. So, this is the main thing, the table retriever. So, for now, I have created one schema.json file which has the complete structure of our database. Okay. So, it has the tables, it has all the tables listed down. Each table has a column. So, all the columns are listed down inside that JSON file. Are the columns nullable? What are the data types? Uh, and the relationship between the tables, like is there any foreign key relationship between two tables? So all of that information is added inside the JSON file. So once the LLM understands which all tables are required, it will try to generate a SQL query for the user's question. Once the SQL query is generated, it will be passed on to the SQL validator. So the role of the SQL validator is to check, uh, I mean, it should only perform select query. Other than that, it should directly ignore that thing. Also, it should check if the uh, query is valid. If there is some syntax error, it should directly, it should retry it, right? So it will pass the error message to the query planner so that next time if the LLM generates the query, it shouldn't make the same mistake again. If the SQL query is valid and correct, it will pass on to the query executor. Here we are doing a tool calling. So the LLM will make a tool call to a tool call in which we take an input of an SQL query and try to execute it. And then whatever the response is, we give it back to the LLM. So once the response is generated, we pass on to the response validator. So the main goal of the response validator is to identify if whatever the user is asking and what the LLM has given is it relevant? Like if it is not, then it will give some suggestions back to the query planner and it will retry this thing to get the best answer the user wants. So once the response validator agrees and it gives a green flag, we pass on the message to we pass on the state to the response generator. So the main goal of the response generator is to uh, make like whatever the output was generated from the SQL query to convert it into a natural language so that the user can understand it, like basic English language. And finally, once the response is generated, the program gets exit. So yeah, this is the complete flow of how the LangGraph part is designed, and I will just show you the demo of it. So before going to the demo, I just wanted to show you the data source. So here we have one database called OMDB. and it has multiple tables. You can see caste, categories, jobs, then movies, people. So all of this data are available. So whatever the question we will ask, the LLM will make a SQL query. It will execute it and retrieve the information from this database. Okay. So let's start with the demo. Let me open my terminal and let me run the program. So for now, we will ask, let's just ask some question from this table people. So let's select this guy, Bill Hunter. So let's ask the birth date of this guy. So let me just open. Uh, can you tell me the birth date of Bill Hammer? It's Bill Hunter. Okay. Let's see how this thing works. So it will first it will classify the intent. So the confidence level is 0.95, which is close to 1. Then it will see if any join operation is required or not. Uh, in this case, there is no join operation required. It will see which tables are relevant. So the table relevant is the people table, which I showed you before. And then it will try to generate the SQL query and validate it. It will execute the SQL query and check how many rows were retrieved from the table, and then it will finally generate the answer. So let me show you the answer. So the answer is somewhere here. So the Australian actor Bill Hunter was born on February 27, 1940. So let's just cross check it. As you can see, he was born on 27th Feb 1940. Now let's ask some question in which there is some join operation required. So here you can see there is one table called movies, and inside that movies there is something called budget. Okay, and there is another table called movies country, and here we have some list of countries. Okay, so what I will ask is that give me the top 5 movies from US which has the highest budget. So it has to perform the join operation. Okay. So let's try that thing. Let me run that program again. Okay. Uh, give me the top 5 movies from US which has the highest budget. So it will again perform the same operation. First, it will classify the intent, then it will plan, then based on the plan it will retrieve relevant tables. After retrieving the relevant tables, it will check if the query is correct. If it's not, then it will retry this thing, then it will try to execute the query. You can see it's retrieving the relevant tables. So it has make the first attempt. Now okay, it has successfully retrieved 5 rows. It says that the response is insufficient, so it is trying the another attempt. Okay, this time the execution has been successfully executed. Okay, so we have the answer. So the top 5 highest budget movies from US are the mix of blockbuster. Okay, so here are the top 5 movies. Okay, uh I guess it gave just the 4 movies, I believe. Yeah, it just gave the top 4 movies, but let's cross check if it's correct or not. So first is Joker. Oh, sorry, it gave the top 5 highest budget movies. So the first is this one, Friday, the 13th part 2, which has a budget of 1.25 billion. Then the second is Joker, third is Private of Caribbean, then the fourth is Mission Impossible, and the last is Star Wars. So let's see if the query is correct or not. So I have prepared something to validate it. So ideally the query should be something like this. Select something from movies M, join the movies countries table on movies ID and movies countries ID, where the country should be US and the budget should not be null, right? It should be ordered by budget in descending way, and it should give the top 5 results. So let me just execute this. Okay, so as you can see, the answers are correct. So Friday, first is the Friday the 13th part 2, second is Joker, then Pirate of Caribbean, then Mission Impossible, and the last is Star Wars. So in this way, the complete LangGraph architecture and orchestration is designed. So hope you like the video.